So here's our problem. We have a small metal bar that's at temperature 20 degrees Celsius, and it's dropped into a container of boiling water. How long will it take to reach 90 degrees Celsius if its temperature is increased by 2 degrees in 1 second? And this is Newton's law of warming. It's not really cooling because this is getting warmer. So we know that we're going to use the Newton's law of cooling model, and we can fill in some details. 20 degrees is the original temperature of the bar when time equals 0. And 100 is in Celsius, the temperature of the medium, the boiling water we're putting it in. So that tells us that our C, our constant, is -80. And now we have our whole model. T, the temperature of T is 100 minus 80 times KT, except for one detail. We don't have the K. But we know if T equals 1 second, right, the temperature is 22 degrees. It increased by 2 degrees in 1 second. So we need K. So 22 degrees is 100 minus 80 times K, e to the K times 1, so just e to the K. And so 39/40ths is e to the K, so K happens to be the ln of 39/40ths. I don't think you have too much trouble figuring that out. And we have the complete model now, as the temperature at time t is 100 minus 80 times e to the ln of 39/40ths times t. To find the time it takes to warm to 90 degrees Celsius, we just need to solve for t in this equation when you put 90 in for t. And so, -10 equals -80 times 39/40ths to the t, whoops, yes, because that's e to the ln of 39/40ths is 39/40ths, so there you have that part. So that means 1/8 equals 39/40ths to the t, and to solve this we do the natural log of both sides. Ln of 1/8 equals t times the ln of 39/40ths. So t is the ln of 1/8 divided by the ln of 39/40ths, so it takes approximately 82 minutes. You can do that last part from a calculator. So it'll take, I'm sorry, that's not minutes, that's seconds. Because if you recall, we got our 2 degrees up in 1 second, so our seconds is our unit of time, and so this would be 82 seconds, so that's about 1 minute and 22 seconds to reach 90 degrees Celsius.